Okay, continue with the fact 2. If a polynomial which is p of x equals to a sub n x to the power of n plus a sub n minus 1 x to the power of n minus 1, okay, plus it goes like that, plus a sub 1 x plus a 0 is a polynomial of degree n, then limit x equals to infinity, okay, p of x equals to limit x equals to infinity a sub n x to the power of n, okay, and the limit x equals to minus infinity p of x it equals to limit x equals to minus infinity a sub n times x to the power of n. And what this fact is really saying is that when we go to take a limit at infinity for a polynomial, then all we need to really do is look at the term with the largest power and ask what that term is doing in the limit, since the polynomial will have the same behavior, okay? And let me give example. Evaluate both of the following limits, and the first one, limit x equals to infinity 2 times x to the power of 4 minus x squared plus 8x minus 5 times x to the power of 4 plus 7, and the limit x equals to infinity, okay, I'm sorry, x equals to minus infinity, and the same numerator and also same denominator. Sorry. And the only difference between these two is that one is going to positive infinity and the other one is going to negative infinity, of course. And sometimes this small difference will affect the value of the limit, and at other times it won't, okay? And let's start with the first limit, and as with our first set of examples, it might be tempting to just plug in the infinity. And since both the numerator and denominator are polynomials, we can use the above fact to determine the behavior of each ones. And doing this gives us, let me write it, okay, and the limit x equals to, let me write here, solution, okay, x equals to infinity, okay, and the 2x to the 4 minus x squared plus 8x minus 5x to the power of 4 plus 7 is equal to infinity over minus infinity, okay, and this is yet another indeterminate form, okay, terminate form. And in this case, we might be tempted to say that the limit is infinity because of the infinity in the numerator, 0. Because of the infinity in the denominator, or -1. Okay, what will we say? There are these separate arithmetic rules at work here, and without work, there is no way to know which rule will be correct. And to make matters worse, it's possible that none of them may work, and we might get a completely different answer. And the -2/5 to pick a number completely at random. So when we have a polynomial divided by a polynomial, we are going to proceed much as we did with only polynomials. We first identify the largest power of x in the denominator, okay, and then factor this is out of both numerator and denominator. Okay, doing this for the first limit will give us like that. Okay. For example, infinity, okay, and the x to the power of 4, and the 2 minus 1 over x squared plus 8 over x to the power of 4, and the x to the power of, power of 4, okay, and the -5 plus 7 over x to the power of 4, okay, and especially these parts will goes to 0, okay, and these parts will be cancelled, okay, so you will obtain only, okay, 2 minus 0 plus 0 over -5 plus 0, so it's equal to -2/5, okay, and the second part of the limit will be the same, okay, this was the first part, and the second part, limit x equals to infinity, minus infinity, okay, and the 2x to the power of 4 minus x squared plus 8x over minus 5x to the 4 plus 7, so it will be again -2/5. Okay, and the second limit is done in a similar fashion, okay, and notice, however, that nowhere in the work for the first limit did we actually use the fact that the limit was going to plus infinity, okay. In this case, it doesn't matter which infinity we are going towards, we will get the same value for the limit, okay. And in the previous example, the infinity that we were using in the limit didn't change the answer, but this will not always be the case, so don't make the assumption that this will always be the case, okay. And let's take a look at an example where we get different answers for each limit, which goes to minus infinity and which goes to plus infinity, but the answer can be changed, okay. The example, this is example 3, I think, and the previous one example 2, right? First one was in the previous lecture. And the same question, evaluate each of the following limits, and the first limit, let me write it, and the limit x equals to infinity, okay, square root of 3x squared plus 6 over 5 minus 2x, and the other one, limit square root of 3x squared plus 6 over 5 minus 2x when x equals to minus infinity. Okay, the square root in this problem won't change our work, okay, but it will make the work a little messier. Let's start with the first limit, which was the x approach to positive infinity. And in this case, the largest power of x in the denominator is just an x, right? And so we need to factor an x out of the numerator and the denominator. When we are done factoring then x out, we will need an x in both of the numerator and the denominator. To get this in the numerator, we will have to factor an x squared out of the square roots, so that after we take the square root, we will get an x, okay? And I mean that solution, let me write it. Infinity 3x squared plus 6 over 5 minus 2x, it equals to limit x equals to infinity, okay, and the square root of x squared parenthesis 3 plus 6 over x squared, okay, over, and the x times, okay, 5 over x minus 2, okay, and it's equal to limit, okay, square root of x squared times square root of 3 plus 6 over x squared, okay, over x times 5 over x minus 2, okay, and it equals to, we know that, okay, my friends, square root of x squared, it equals to absolute x, okay, and because of, we must be careful, really careful with the square root in this problem, because don't forget that this one and the square root's always positive, and so we need to absolute value bars on the x to make sure that it will give a positive answer, okay? This is not something that most people ever remember seeing in an algebra class, and in fact it's not always given in an algebra class, okay? And however, at this point it becomes absolutely, we tell that we know and use this fact. Using this fact, the limit will be, okay, limit x equals to infinity, okay, and the absolute value of x times square root of 3 plus 6 over x squared over x times 5 over x minus 2. Okay, now we can't just cancel the x's, okay, this is important. We first will need to get rid of the absolute value bars, and what was it? And the absolute value of x equals to x, okay, if x is larger than or equal to 0, minus x if x is less than 0. Which case is true for us, okay? And in this case, okay, we are going out to plus infinity, so we can safely assume that the x will be positive, okay, and this part, okay. So we can just drop the absolute value bars, okay, and it will be now limit x equals to infinity x times square root of 3 plus 6 over x squared over x times 5 over x minus 2, and now it can be cancelled, okay, and after that it's equal to limit x equals to infinity square root of 3 plus 6 over x squared over 5 over x minus 2, okay, and this part will be 0, okay, and let me write them, 0, 0, so square root of 3 plus 0 over, okay, 0 minus 2, so it's equal to minus square root of 3 over 2, okay. This is the first part solution. And let me continue. Take a look at the second limit, okay? And the second limit was the limit x approaches to minus infinity, square root of 3x squared plus 6 over 5 minus 2x, okay? And partially we know that limit is equal to absolute value of x times, okay, square root of 3 plus 6 over x squared over, okay, x times 5 over x minus 2, okay. And in this limit we are going to minus infinity, so in this case we can assume that x is, okay, we can assume that x is negative. So in order to drop the absolute value bars, in this case we will need to take on a minus sign as well, okay. So the limit will be limit x equals to minus infinity, and this part will be minus x times square root of 3 plus 6 over x squared over x times 5 minus x minus 2, and then this part will be cancelled but minus will be remain, and after that x equals to minus infinity minus square root of 3 plus 6 over x squared over 5 over x minus 2, okay. So it will be minus and the square root of 3 over, okay, and the minus 2, so it will be square root of 3 over 2. And as you see, this part is negative but this part is positive. Both of them are not equal to each other. Okay, so let me give you another definition. The function f of x will have a horizontal asymptote at y equals to L if either of the following are true. Limit x equals to infinity, f of x equals to L, and the limit x equals to minus infinity, f of x equals to L. Okay, this is our definition about the horizontal asymptotes. We are not going to be doing much with asymptotes here, but it's an easy fact to give, and we can use the previous example to illustrate all the asymptote ideas we have seen in both this section and the previous section, of course. The function in the last example will have two horizontal asymptotes. It will also have a vertical asymptote. And let me give you a graph of the function showing these, okay? And it will be okay, and we have two horizontal asymptotes, The first one, I think the square root of 3 over 2, and the another one is minus square root of 3 over 2. Okay, and these are the horizontal asymptotes, and we had the vertical asymptote. Okay, and it was the x equals to this point. Okay, and when you wanted to sketch it, sorry, you will obtain like that. Okay, and this is our functions graph. Okay, and let's continue with another example. And evaluate each of the following limits again, and the first one is limit z equals to infinity for z square plus z to the power of 6 over 1 minus 5 z cube, and the limit z equals to minus infinity 4 times z square plus z to the power of 6 over 1 minus 5 times z cube. Okay, and do the first limit, and in this case it looks like we will factor a z cube, okay, out of both the numerator and denominator. Remember that we only look at the denominator when determining the largest power of z here. There's a large power of z in the numerator, but we ignore it. Okay, we only look at the denominator when doing this. Okay, so doing the factoring gives us limit z equals to infinity. Okay, and what will it gives us z cube times, okay, and 4 over z plus z cube over, okay, z cube times 1 over z cube minus 5. Okay, and it will give us this portion will be cancelled again, and then it's equal to limit z equals to plus infinity 4 over z plus z cube over 1 over z cube minus 5. Okay, when we take the limit, we will need to be a little careful, and the first term in the numerator and the denominator will both be 0, and however the z cube in the numerator will be going to plus infinity, and in the limit, and so the limit will be like that. That means this will goes to 0 and it will go to 0. Okay, and so that can say the limit z equals to infinity. Okay, and what will it be? And it will be, I'm sorry, we can write this part. Okay, and this will be 0 plus infinity over 0 minus 5, so it will be minus infinity from this sign. Okay, and now we can look the second limit. Okay, and what will it be? It will be easy to see, limit z equals to minus infinity. Okay, and the same idea. Okay, for z square plus z to the power of 6, 1 minus 5 z cube, So it's equal to limit z equals to minus infinity 4 over z plus z cube over 1 over z cube minus 5, okay, and it will be 0 minus infinity, okay, over 0 minus 5, so it will be plus infinity, okay, and the answer is positive since we have a quotient of two negative numbers, okay. So, and let me continue with another example. Limit t equals to minus infinity, okay, t square minus 5t minus 9, and 2 times t to the power of 4 plus 3 times t cube, okay. In this case it looks like we will factor a t to the power of 4 out of both the numerator and denominator, and doing this will give us limit t equals to minus infinity, okay, and the t to the power of, t to the power of 4 times, okay, 1 over t square, okay, minus 5 over 3 cube and minus 9 over t to the power of 4, and in the denominator part t to the power of 4 times 2 plus 3 over t, okay, and after that this part will be cancelled, over t square minus 5 over t cube minus 9 over t to the power of 4, and the 2 plus 3 over t, okay, and after this part you can easily see it will be, okay, and 0 over 2, so it's equal to 0. In this case, using fact 1, we can see that the numerator is 0, and so since the denominator is also not 0 but the fraction 0, the fraction, and hence the limit will be 0. And in this section we concentrated on limits at infinity with functions that only involve polynomials and or rational expressions involving polynomials. There are many more types of functions that we would use here, as you see from the examples. That is the subject of the next section, okay, and let me continue with the limits at infinity part 2. Okay. And in the previous section we looked at limits at infinity of polynomials and or rational expressions involving polynomials. And in this section I want to take a look at some other types of functions that often show up in limits at infinity. The functions we will be looking at here are exponentials, natural logarithms, and inverse tangents, okay? And let's start by taking a look at some of very basic examples involving exponential functions, okay? Let me give them. Evaluate each of the following limits. The first one, limit x equals to infinity e to the power of x, and the limit x equals to minus infinity e to the power of x, and the limit x equals to plus infinity e to the power of minus x, and limit x equals to minus infinity, okay, e to the power of minus infinity. And the solution of them, there are really just restatements of facts given in the basic exponential section of the review. So I'll leave it to you to go back and verify these one, okay? Only I'll give the results, okay? And the limit x equals to infinity e to the power of x, okay? And it will be equal to plus infinity, and the limit x equals to minus infinity e to the power of x, it will be 0, and the limit x equals to plus infinity e to the power of minus x will be 0, and the limit x equals to minus infinity e to the power of minus x, it will be plus infinity. Okay. The main point of this example was to point out that if the exponent of an exponential goes to infinity in the limit, then the exponential function will also go to infinity in the limit. Likewise, if the exponent goes to minus infinity in the limit, then the exponential will go to the 0 in the limit. Okay, and let me give you some examples and illustrate these ideas. Okay. Limit x equals to infinity, okay, e to the power of 2 minus 4x minus 8 times x squared, okay, and another one, limit x equals to minus infinity, okay, e to the power of 4 minus, I'm sorry, this part will be t, of course, and the 5 times t squared plus 1, and the last one, limit z equals to 0 from right hand side, okay, e to the power of 1 over z, right? Solution: x equals to infinity e to the power of 2 minus 4x minus 8 times x squared. Okay. In this part, what we need to note, okay, using fact 2, which is above, is that in the limit, the exponent of the exponential does the following. That means the, okay, and we can say the limit x equals to infinity, okay, 2 minus 4x minus 8x squared, and which is the minus infinity. So we can say the, okay, limit, okay, x equals to infinity e to the 2 minus 4x, okay, minus 8x squared. So the exponent must go to 0, okay. And the second part, let me give you, which was the limit t equals minus infinity e to the power of t to the 4 minus 5t squared plus 1, I think. And so limit x equals to, t equals to minus infinity, t to the power of 4 minus 5t squared plus 1. So it will be plus infinity. After that we can say limit t equals to minus infinity, okay, e to the power of t to the 4 minus 5t squared plus 1. So it's equal to plus infinity. Okay, and the last one, which is the limit z equals to 0 from right hand side, e to the 1 over z. Okay, so we know that limit z equals to 0 from right hand side, 1 over z, it equals to plus infinity. So limit z equals to 0 from right hand side, e to the power of 1 over z, it's equal to, okay, infinity. Okay, and let me give you simple examples. Limit e to the power of 10x, okay, and the minus 4 times e to the power of 6x, okay, limit x equals to infinity, and the plus 3 times e to the x plus 2 times e to the minus 2x, and the minus 9 times e to the power of minus 15x. Okay, and let's solve this. The only difference between this limit, we will take the limit as we go to plus infinity, and let me write it, and what will we do? And the first one, please think about it. And it will be, I think, the plus infinity, okay, and the minus infinity, and plus infinity, and plus 0, and minus 0. And the last two terms aren't any problem, and they will be in the next part, however. Do you see that? And the first three are problem, however, as they present us with another indeterminate form. And okay, and so what will we do it? And we must do, okay, we take the e to the power of 10x out of the factor, okay, and so we can evaluate the real limit, okay. So it will be limit x equals to infinity, okay, e to the power of 10x times, okay, and it will be 1 minus, okay, 4 times e to the power of minus 4x, okay, and plus 3 times e to the power of minus 9x, and plus 2 times e to the power of minus 12x, and the minus 9 times e to the power of minus 25x, okay, and all of this part will go to 0. Okay, so the solution will be easy now. So we can say the infinity times 1, and it's equal to infinity. Okay.